So we're going to go ahead and look at notes 1-3 for Algebra 1, and we're looking at real numbers here. And our essential question is, can I order real numbers and simplify square roots? So first of all, I kind of have a little graph set up here, and I want you to know that all of these examples I'm going to give you are real number examples, okay? And we can take our real numbers and we can break them into two different categories. That kind of is a hard color to see. Let's do a little blue. And our two categories are, we have rational numbers and we have what we call irrational numbers. So I'm going to start with the definition of a rational number. And a rational number is a number that can be written as a fraction. So a number written as a fraction. So I'm just going to write written as a fraction. That is a rational number. So we have all kinds of numbers that can be rational numbers, because there's all kinds of numbers that can be written as fractions. And so let's talk about what would be our examples of, well, let's just write some fractions down here. How about we do one example as -1/4. That is a fraction. And if I have the negative sign, doesn't matter if it's positive or negative, but it can be written as a fraction. The square root of 9. Do you know what the square root of 9 really equals? Well, it really equals the whole number 3. And the whole number 3 can be written as a fraction, 3/1. You can take any number and write it as a fraction by placing it over 1. Let's get a decimal in here. So what about 75 hundredths? 0.75, like 75 cents. You write that as a fraction, as 75/100. So any number written as a fraction is a rational number. So our integers, some examples of integers here. Our integers are positive and negative. So like -3, comma, -2, comma, -1, comma. We also have 0, and we could have the positives of those as well. So these are all examples of integers. If we talk about whole numbers, sorry, I'm having a hard time getting my new text box. There we go. Whole numbers are positive, first of all, and it does include 0. So, and we know that this go on forever. And we know these are rational numbers because all these numbers can be written as a fraction. So let's go ahead and look at what we would call natural numbers. And natural numbers do not include 0. And they are positive. So, and we can keep going. I think you see the pattern here. So here's just some vocab for you on the difference between a natural number, a whole number, and an integer, as well as what a rational number is, which rational numbers are all numbers that can be written as a fraction. So let's talk about irrational numbers, and I bet you can take a guess at what an irrational number is. An irrational number cannot be written as a fraction. So if we have an irrational number, we cannot write it as a fraction. And to give you some examples of that, we know that pi is an irrational number. It cannot be written as a fraction. It goes on forever and repeats. Does not repeat, I apologize. Does not repeat. Goes on forever and does not repeat. We know that if we were to do the square root of 10 in our calculator, the square root of 10, it goes on forever and does not repeat. You cannot write it as a fraction. And to give you another example, this would also be an irrational number because we cannot write it as a fraction. I'm totally well aware that there is a pattern, but if you are going to have an irrational number, it cannot be written as a fraction, so it is going to go on forever, meaning you'll probably see the 3 dots at the end of it, and there is nothing that repeats. Nothing that repeats. So let's look at this bottom question here on how do I order numbers from least to greatest. And I'm going to tell you that the most important thing for us to do when we do this is we need to make sure that we change them all to the same form. So, for example, if I give you a list of numbers, and I'm going to give you a list of numbers here, we're going to put some numbers in order from least to greatest. And I'm going to tell you the first number is the square root of 4. And then I'm going to have 4/10. And then if I have a negative 2/3. And then the square root of 2. And negative 1/2. In order to put all of these in order, we want to change them all to the same form. I highly suggest changing them to changing them to decimals. I do not suggest. I don't think you want to change them all to fractions. Fractions would not be fun. So let's change all of these to decimals. Square root of 4 we know is 2. 0.4, it's already in decimal form. It's 4/10. Think of it as like 40 cents. Negative 2/3, if you divide that on your calculator, you get negative 0.6 repeated. It's going to go on forever, but it's repeated and it's written as a fraction, so technically it's a rational number. The square root of 2, if you do that one on your calculator, we get 1, I'm going to round it, 0.41. And negative 1.5 is already in decimal form. So now that we've changed them all to decimal form, we can easily put these numbers in order. And how I suggest doing that is we know that the number that is the smallest or the least is going to be on the left, and the greatest is going to be on the right. And we're thinking, picture a number line. Picture a number line right now. And so we're going to start with those negative numbers first. They're going to be my smallest. We know 0 goes right in the middle. I know 0 is not one of my numbers, but feel free to put 0 as one of the numbers. So to the left, we're going to have all of our numbers that are less than 0, all of our negatives. And if you owed someone 66 cents or you owed someone $1.50, we know that $1.50 is actually going to be a smaller number, a negative $1.50 is also going to be a smaller number. It's going to be least. So negative 1.5 is going to be the smallest. And then my next negative number, or my only other negative number, is negative 2/3, and that is closer to 0. It's actually bigger than negative 1.5. So I can write that right here. Did you also notice I wrote the original form? Then we have 0. Next, we are looking at the whole number 2. Think of $2, 40 cents, and $1.40. So we know that 40 cents would come next. And I always try to convert things and think of it as money to help us put numbers in order. And then we know, I'm going to put commas between these. And then we know that we're going to have the square root of 2. $1.41 would come next. And the biggest number in this group is the square root of 4. And you'll notice I put my numbers in order from least to greatest, starting with the negatives being the least. And I wrote the original form. Let's go ahead and look at our next slide that I don't think will take us very long. We want to talk about what a perfect square is. And a perfect square is when the square root is an integer. So we're going to type that down. When the square root So for example, a perfect square would be the square root of 100 because we know that is an integer 10. So perfect square is when you have a square root and you get an integer. So you could probably tell me all of them from this. We know the square root of 1 is 1. We know the square root of 4, we did this on the last one, is the number 2. What's going to give me the number 3? You got it, the square root of 9. And you could keep going and add to your list. You should know perfect squares all the way up to at least the 10. Square root of 16 is 4. 4 times 4 is 16. So I'll let you finish that. We're going to look at one below. If we look at example 2 here, we are talking about or trying to evaluate and find the square root of these numbers. These are perfect squares. These are going to be pretty. The square root of 25 is the whole number 5. We know what the square root of 16 is. It's the number 4. But what do you notice right in front of that? You notice a negative sign. So just attach the negative sign with it. And the last one, and this is I've been going through what I call test questions. I'm going to star it because it's going to be a test question. The square root of 25/64. It's a fraction. Don't freak out. Don't type it in your calculator either. You can do this quickly in your head. We can write this one as the square root of 25 divided by the square root of 64. So we're just taking, what is the square root of 25? You know that. You did it in the problem up above. It's 5. Divided by, what's the square root of 64? And it is 8. And so your answer is 5/8. Do you notice that when you take the square root of a number, you actually get rid of that radical symbol? Okay, the radical symbol is like the square root symbol here. So when you take the square root, it is gone. So we're going to practice putting numbers in order and taking square roots. Have a good one.